negative 3. So what I'm going to do is I'm going to look at my equation, which is y equals x squared. Everywhere I see an x, I'm going to plug in a negative 3. Okay? So I started with x squared, but x is no longer x, it's now negative 3. Okay? So negative 3 squared is what? Maggie, calculate time. Positive 9. Okay? Very good. Okay, now John, this is where I'm picking on you. What is my point going to be using my x and my y values here? Not, well, sort of, no. Right, because your x is still negative 3, right? And your y, the related y to your x is going to be 9. Okay. Yeah?
So you're trying to find y?
You're trying to find what the y value is for each x.
Okay.
Yes, and that's what we're going to do here. We're eventually, ultimately going to graph these points on the right-hand side. That's what we're going to end up trying to do here. All right?
So negative 3 is y?
Yeah, you know, your y, your x is negative 3, because that's what we're saying. And negative 3 squared is going to be your y value, which happens to be 9. Right, so you're going to send it. So right up to you. No?
Wait.
Yeah, go ahead.
So you're solving that equation to find y?
Yes.
To plot on the graph?
Yes, that's what we're doing there. So I'll get you started here. Tori, okay? That's all we do. You're not done yet, Tori. That's correct. We got to keep going. What is negative 2 squared equal to? Positive 4, right? Because like 2 negative make a positive is 4. All right, Michelle, what's that point on my graph going to be?
Negative 2, 4.
Yeah, negative 2.4. Okay, so you see what's sort of happening here? You sort of get how we're starting this? Yes, a little bit. All right, Sahil, you're up. Can you try and do the inside part? Go ahead. Y equals. Yeah, negative 1 squared. Right, because remember, this is the equation we're using, y equals x squared, right? Our x is no longer x, now it's negative 1. Right? What's Sahil? What's negative 1 squared? Right, like negative 1 times negative 1 is 1, right? We'll have to check what's going on there. Cassie, you can help him after, but before that, what's the point on the graph going to be here? Yeah, good. Okay, your x is negative 1, so your y is number 1. You help us discuss it. Okay. Alexandra, what's the next middle part, please? Yeah, y equals 0 squared. 0 times 0 is? Good.
How do we know brackets around like the number?
Because the thing you have to remember with that is it's the entire thing is squared. And the reason I'm doing that is because like when you're doing negative 3 squared, you're also squaring the negative, right? Because remember this on the first test, and remember the question was, what does that equal? Well, this is actually negative 9, right? Because only the 3 is being squared in this case. Remember this question in the first test? Remember I gave you that one? But negative 3 squared is just equal to positive 9.
Okay.
Right? So half is the entire thing is squared. All right, Teresa, what's the point going to be on the graph, please?
Gonna be 0 and 0.
Is it starting to come together? What's happening here? Yes? Can I put up the pace? Yes. Yes? Okay. You guys are done? Can I fill it in as fast as I can? Okay. So here we go. So it's going to be y equals 1 squared, which happens to be 1. So this is 1 and 1. Y equals 2 squared, which happens to be 4. 2 and 4. And then y equals 3 squared, which happens to be 9. And that's 3 and 9. Okay? Sort of okay where most of those things came from? Yes? Now we gotta get to graph it. And when we're going to graph this one, I'm going to let you guys actually take a stab at this first and try yourselves. Before you begin graphing though, one of the things I did not say yet that's important for graphing is that you have to make sure that every point fits on your graph. So what should the span of my graph be left and right from where to where?
9.
Careful, straight. Julia, go ahead.
9.
Okay, it has to get up to 9 on my y. So do I need to go down to negative 9? No.
Not
Right?
all the time.
No, not in this case. What's my lowest y value? 0. So if you can draw your graph from 0 to 9, that's all you need. Maybe negative 1 to make it look like a graph, like negative 1 to 10. So left and right, what has to go from where to where? Where do my axes go from where to where? Got it? Those are the y values going 0 to 9. For the axis, yeah.
-3.
Negative 3 to 3. Right, so maybe go, when I'm doing this graph, I'm probably left and right, probably going negative 4 to positive 4, and maybe like negative 1 to 10, just to leave a little extra room on your graph. Okay, so you might need a little bit bigger graph this time, so everyone got that? So you have to make sure all the points fit. So many years, I'm an old man, I've been teaching for so long, I see so many beautiful graphs that look like this, and all of a sudden I'll see a graph like this because they haven't planned properly. Okay, right? They've had points off the graph because they haven't planned it. So plan it out, you know what the points are going to be, make sure all of your points fit on the graph. Alright, so take a second. When I say second, I mean about maybe 3 or 4 minutes and graph it. I'll help the test rate. Okay, I'm going to graph this as quickly as humanly possible, and then we'll get moving here. As we mentioned before the break, the points that we're going to need are probably from about negative 1 to 10 on the y values, so from negative 3 to 3. So because that, I can sort of put my graph, I have no negatives in the y, so I can sort of put my graph, oh goodness, not at all actually. Okay. Now, tell me something I should put on this graph before I begin, please. Noah. Very good. Okay, so y-axis, I'll put that right there. And this right here is my x-axis. Thank you, Noah. Somebody else, what else should I put on this graph before I begin? Yes? Arrows. Always arrows. Again, we only did from negative 3 to 3 on this graph. And I'll sort of get you guys to guess where it would continue this time when I'm on point 4. What else in my graph? Numbers, okay? I'm going to start with 0 here. I have to get just to 3, so I'm going to go 1, 2, 3. Negative 1, negative 2, negative 3. I have to get up to 9, so we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Yes. Then you're saying, oh, that's so much work. Okay, it takes about an extra 3 seconds is all it takes. Like literally, that's all it takes. Okay, so it's not all that much work. And not only that, if you do this, every math teacher you ever have will love you. Okay, in all honesty. Okay, because this is the #1 grade teachers have sloppy graphs. Okay, sorry. Here we go. So first point is negative 3 and 9. Chris, where's negative 3 and 9 going to be?
The x-axis on the negative and then up until 9.
It's going to be over here someplace. I'm going to put a circle on it. If you labeled A, B, C, D, F, G, that's fine. I didn't. Okay, that's okay. Negative 2 and 4. Austin's going to be what?
You're going to go to negative 2 and
Yep.
up to 4.
Wonderful. Good. Maverick, where is the negative 1 and 1? Good. Negative 1 to the left. 1. Okay, 0 and 0, I'll take that one. That is right in the middle. Now this is the part that gets people fuzzy about graphs. And this is why I picked one of the first graphs that you did as something weird. Okay, because this is a weird graph for grade 9s. Okay, probably you've never seen anything like this other than in your everyday life, but as far as in your paper. Next point, Leah, is going to be what? 1 and 1, which is?
Just 1 on the right and then up.
Yeah. Okay. What happens for people who say, well, shouldn't have sort of carried down that way? Well, you guys don't know anything about that yet. That's why I picked a weird one here. Noah, what comes next? 2 and 4, which is where?
So finding 2 on the X and 4.
And then I'll do 3 and 9. Okay, that's what we graphed. We didn't tell you guys this hint, I'm going to tell you this right now. Connect the dots, please. Okay, because every in-between point. Now, it actually will be a curve, not a...
Why is it a curve?
Why is it a curve? Because of the squared, right? Because if you take a look, this is different. Like if you do a ruler, it's not a straight line. Like it's a straight line here, and then a straight line there, and then a straight line there. If you were to put more points in there, there'd be more straight lines curving like this. Okay, so if you were to put a whole bunch of rulers, you know what I mean? If you were to put like 2.9, 2.8, 2.7, 2.6, 2.5, there's no straight lines anywhere on this graph. It's always curving the whole way. Okay, then I'm going to do this side as
Is it
well.
wrong if you use a ruler?
No, I'm going to, in grade 9, it's fine. Okay? It's okay to use a ruler in this grade 9. Now, one thing I'm unhappy with this graph, actually 2 things I'm unhappy with this graph. You don't know what they are. Did anyone see a problem with this? That's looking good, but there's 2 things I can add. Anyone think of something I might want to add there? Yeah, go ahead.
Like the letters?
Yeah. You can indicate what points if you want to. I don't require that of you only because if you label your graph, I'm somebody to make sure that all this is neat. So if you label everything neat, you should be able to see that's at -3 and 9. But some teachers in elementary school would make you do like this sort of thing, right? And you can do that if you want to. Well, that's not incorrect, but don't require that of you. Okay? 2 other things I do. Number 1 is, oh, sorry, Joel, go ahead.
Title.
Title is wonderful. What's a suitable title for this graph? Sorry.
Finding Y values.
Yes, you can do that one. I'm going to get even more detailed than that. It is finding y values. I'm probably just going to call this y equals x squared. Okay. Where did I get that magical title of y equals x squared from?
Equation.
That's the equation. Okay. So that's all you need to do. As well, if you are like Teresa and you want to save graph paper, like I don't know if you know this, Teresa's likes trees. She doesn't want trees to be cut down, and I'm just joking. Okay. But let's say she was like that, and you want to save graph paper, and you wanted to put 2 or 3 graphs on the same piece of graph paper. That's okay for your homework to do. Okay, right. But what you do is either use different colors for each graph, or you might want to put right beside the end of this graph, put a little y equals x squared right there so you can see what the graph was if there's more than one graph. There's one other thing, and this one's a biggie, okay? For me, I also want you to put arrows on the end of the graph. And continue it on. Now, the reason for that is I only did this graph from -3 to 3. I could have easily have said to you, from -20 to +20. Okay, right? Where would +20 be? If x was +20, where would that be? Where would the y value be? If x was 20, let's say I did continue all the way over here, where would your y value be? It would be 400, okay? So 400 is where on my graph? Way up, outside of the school, you know what I mean? Like this is up halfway to heaven, okay, is where 400 would be, okay? That's pretty high, okay? So the thing is, as long as the arrows you show the graph would continue for bigger points, okay? Someone okay? Yeah.
If you did a big one like that, couldn't you make it like, instead of row 1, 2, 3, 4, you could do it like 10, 20?
Oh, totally, yeah, and you definitely could. You could definitely change. Very good. So I don't know if you guys heard that. So they said, let's say you did do a bigger graph, and on the next example, that's what we're going to do, and I'll tell you what to count by. So we're going to pick one that's maybe count by 10s or count by 20s or something, and that works too. Okay, excellent. Okay, example 2, and I think, how time we got? I have to slow down. I'm too excited with graphs here. Here we go, example 2.
You mean example 3?
Ready? That's what I meant. Later, I meant that. Okay, we're going to say, Alexander works at a clothing store. Where she earns $40 per week. Plus 5% of the clothing that she sells. Again, Alexandra works at a clothing store where she earns $40 per week plus 5% of the clothing that she sells. We're gonna say A, model this with an equation. I'm gonna tell a joke here. I'm gonna hit pause and then tell a joke.
Are you trying to find